Pushing force applied obliquely to move a body over a rough horizontal surface. We have to find the expression of pushing force applied obliquely to a body, to move it on a horizontal rough surface. Pushing force applied obliquely to a body to move it on a horizontal rough surface. This is a block or body of mass m which is placed on a horizontal rough surface. The body has the weight mg. Weight of the block or the body, that is mg, is acting vertically downwards. Mg is the actual weight of the body which acts vertically downwards. An external force Fex, an external pushing force Fex is acted obliquely to the body at an angle theta with the horizontal direction. Fex be the external force which is applied obliquely to the body which is placed on a rough horizontal surface. Fex is the pushing force. Fex is the pushing force which is applied obliquely to the body. Now we can extend the direction of applied external force Fex in forward direction. Fex is extended in forward direction. Now we can denote the weight of the body mg. Mg is the weight of the body which acts vertically downwards. Mg acts vertically downwards, and we can denote a backward direction. We can denote a backward direction with respect to the forward direction. And also we have drawn a rectangle taking the external force Fex as the diagonal. The external force Fex is acted obliquely at an angle theta with the horizontal direction. We can consider the vertically opposite angle as theta also. The external force which is applied obliquely to the body, that is Fex, is resolved into two rectangular components. The rectangular component in horizontal direction is Fex cos theta. Fex cos theta is the rectangular component of the force which acts in horizontal direction. Similarly, the rectangular component of the applied force acting in the vertical direction is Fex sin theta. Fex sin theta is the rectangular component of the applied force Fex which acts vertically downwards. Now we can denote the normal reaction force R. R is the normal reaction force to the body applied by the rough surface. We can consider the direction along which the body will be moving. This is the direction or horizontal direction along which the body is at the verge of moving. The body will be at the verge of moving due to application of the force applied obliquely to the body. If the body is at the verge of moving over the rough surface towards right, in that case limiting friction Fl, in this case limiting friction Fl will act tangentially over the rough surface, that is Fl. Fl is the limiting friction which acts tangentially on the surface in contact between the body and the rough surface, and this limiting friction opposes the relative motion between the two bodies. Let Fex be the external force. Fex be the external force applied to a body of mass m placed on a rough horizontal surface obliquely at an angle theta with the horizontal direction. At an angle theta with the horizontal direction. Fex be the external force applied to the body of mass m placed on the rough horizontal surface obliquely at an angle theta with the horizontal direction. The applied external force Fex is resolved into two rectangular components. The applied external force Fex is resolved into two rectangular components, that is Fex cos theta in horizontal direction and Fex sin theta in vertically downward direction. Now the body will be at the verge of moving. The body will be at the verge of moving over the rough horizontal surface, provided or under the action of the rectangular component of applied external force Fex cos theta, the rectangular component Fex cos theta, and the limiting friction Fl, will come into play. Limiting friction Fl will come into play on the surface in contact. In this case, acceleration of the body will be 0. At equilibrium, rectangular component of applied external force Fex acting in horizontal direction will be equal to the net force acting in the opposite direction, or comma Fex cos theta will be equal to limiting friction Fl, or comma Fex cos theta equal mu into r, where mu is the coefficient of static friction. Using the law of static friction, limiting friction Fl is equal to mu into r, where mu is the coefficient of static friction, and r is the normal reaction. Capital R is the normal reaction. Therefore, Fex cos theta equal mu into r, which is equation 1. Considering the equilibrium condition, in vertical direction, we can write rectangular component of applied external force acting vertically downwards will be equal to net force experienced by the block or the body acting in the vertically upward direction. Net force experienced by the body acting vertically upwards, or comma Fex cos theta, it should be Fex sin theta, not Fex cos theta. Fex sin theta will be equal to net force acting in upward direction is r minus mg. Therefore, r is not equal mg in this case. Normal reaction r will be equal to Fex sin theta plus mg. R will be equal to Fex sin theta plus mg, which is equation 2. Using equation 2 in equation 1. We get Fex cos theta as equal mu r, or comma Fex cos theta equal to mu into Fex sin theta plus mg, or comma Fex cos theta minus mu Fex sin theta is equal to mu into mg. Now Fex is taken common, we get Fex will be equal to mu in mg divided by cos theta minus mu sin theta. Fex is equal to mu mg divided by cos theta minus mu sin theta, which is the force applied obliquely to a body at an angle theta with the horizontal direction to move it along the rough horizontal surface or plane. Fex is the force or pushing force applied obliquely to the body at an angle theta with the horizontal direction to move it along the rough horizontal surface or plane. Now the coefficient of static friction. Now the coefficient of static friction is given by mu equal tan theta, where theta is the angle of friction. Mu is equal tan theta L, where theta is the angle of friction. Therefore, Fex is equal tan theta L mg divided by cos theta minus mu sin theta. So finally, we get Fex as is equal tan theta L mg divided by cos theta minus tan theta L sin theta, or Fex equals sin theta L by cos theta L into mg divided by cos theta minus sin theta L by cos theta L into sin theta, or Fex will be equal to sin theta L by cos theta L mg divided by, doing LCM we get cos theta into cos theta L minus sin theta into sin theta L divided by cos theta L, or Fex is equal to mg sin theta L divided by cos theta into cos theta L minus sin theta into sin theta L. Therefore, Fex is equal to mg into sin theta L, sin theta L divided by cos theta plus theta L into mg. Fex is equal to sin theta L divided by cos theta plus theta L into mg. That is the expression of pushing force applied on a body obliquely at an angle theta with the horizontal direction to move the body in the rough horizontal plane. Fex is equal to sin theta L divided by cos theta plus theta L into mg, which is the pushing force applied obliquely to a body at an angle theta, with the horizontal rough surface, at an angle theta with the horizontal, to move the body over the rough horizontal surface, or horizontal plane. Pushing force applied obliquely to the body is Fex, which is cos sin theta L into mg divided by cos theta plus theta L. Fex is equal to sin theta L divided by cos bracket open theta plus theta L into mg. That is the expression of pushing force applied obliquely to a body at an angle theta with the horizontal to move it over the rough horizontal surface.